Supervised learning is an integral part of machine learning. So with the help of supervised learning, we either try to predict something or classify something. And in this particular course, we are going to look at two most important algorithms in supervised learning, which are logistic regression and naive Bayes.
Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.
In this part, we are going to talk about what is machine learning. And also we will have a look at what are the types of machine learning we have and also what is supervised learning. So let's go to agenda and let's have a look at what are the topics we are going to cover in this part. So first we are going to talk about why do we need machine learning? What is the need of machine learning? What are the problem we are facing where we can actually solve those problem using machine learning? Then we will see what is machine learning, right? Then we will have a look at what is the life cycle to build a model using machine learning. Then we will see what is supervised learning. So basically in machine learning, we have three parts. One is supervised, unsupervised, and reinforcement learning. From there, we will have a look at what is supervised learning. What are the features we have in supervised learning? Then in supervised learning, we have few algorithms. From those algorithms, we are going to cover two particular algorithms. One is Naive Bayes algorithm and second one is logistic regression. So let's get started with the first topic. Why do we need machine learning? So in the past, if we look at closely that in the past, what we used to have a data in a very structured or in a format way. But how? Because that time our data was in a very sorted way and the data was not in a huge format, right? That time the people or the human basically used to enter the data. Now, as we are going towards an online transaction, we are going to book our ticket online. We are going to ordering food online. We are going somewhere for that. We are booking cab online, right? For all those things, we prefer to go for online. If you talk about me as a person, I cannot stay without my phone because most of the day, whatever the thing I need, I can get everything from my phone. Right? Because there are lots of applications are there. So when you are actually using those online transactions, the respective companies are actually taking your data. If you ask me why, because maybe you can think of what are they going to do by taking our data, what I'm ordering food or where I'm going. But yes, there is a connection of taking your data because they can make you a cluster, maybe not the cluster right now, you cannot understand, but you can think that maybe they try to understand the similar customers like you who actually maybe you love biryani or you love chow mein, right? So maybe you basically love Indian food or you love Chinese food, right? So in this case, they can actually cluster the same customers who actually love Indian and who actually also explore some new dishes. As a recommendation, they can recommend those dishes. Right? So in Amazon, if you just go for shopping, you can see there is a there is a portion where it comes that you also may like, right? So basically this is nothing but the recommendation from the same customers like you. So it's one kind of a example I have given you that what a company can do by taking your data. But yes, there are lots of things. They can actually train their model with the data you are giving, or they can focus their sales, or they can try to understand that what are the restaurants, if we talk about Swiggy or Zomato, by ordering food from a particular restaurant from a multiple time, they can understand, they can figure it out, maybe this restaurant is on high demand, right? They can put some sales on there, right? So basically that's nothing but the sales prediction, making business more in a good way, right? And also making their customers satisfied. So all those things can be done by the data. Yes. So that's why now all of the companies think that data is the new oil, right? So in this case, what we used to have in the past, the data was in a very sorted manner. But now, as we are actually going for lots of things, that time our data volume becomes very high and no manual entry are there. Like there are few cases where the manual entries are there, but trust me, for all of the cases it's automated. So that time there is a error is very normal. So now the data are not in a structured way. They should be in unstructured or a semi-structured data. So in this case, when we have the traditional tools to handle those data, they cannot cope up with this massive amount of unstructured or semi-structured data. That time you need to find it out a solution. So this is your problem, and finding out the solution, you need to go for using some other tools which can actually handle those data. After handling those data, what will you do with those data? So if you cannot use those data, there is no point of putting so much effort on those unstructured or those messy data basically. That time machine learning comes into the picture. Machine learning has lots of algorithm which actually help you to make. Right. So machine learning has lots of algorithm which will actually help you to make your own model. For that, it will reduce the human effort. It will reduce the cost, the production cost, and also it gives you most perfect result. So that's why we need machine learning. And with time, machine learning is actually booming with time. Right. And also machine learning is getting popular for this. Like all of the companies like Google, Ola, Uber, I mean, we can talk about the all the companies, maybe it's a startup or maybe it's a MNC, they actually going towards this concepts because of these flexibilities, right? So this is why we can say we need machine learning. Now we will have a look at what is machine learning. So what is machine learning? So if we can look at machine learning is a subset of artificial intelligence. In short, it's known as AI that allows the system to automatically learn and improve from experience without being explicitly programmed. What actually it actually mean by? So basically what is actually want to say when you have data, you basically need to split your data in two parts. One is training data, one is testing data. From the training data itself, what you need to do, you will train your data, right? So you will not train your data, basically you will train your model from using those data. After you train your model, you just need to give a unknown data to your model to make a prediction out of it, how your model is working when you give a new data. If you see your model is working perfectly fine, then you can say, hey, my model is ready, and you can use my model, right? So this is the whole structure of machine learning, how machine learning works. So now we will have a look at what's the difference between traditional versus machine learning. Yes, this is the main catch. That's why you have to understand what's the difference between traditional programming versus machine learning. The first reason is the traditional programming, every time you give the input data, you will get an output, and every time you need to program. But in the case of machine learning, you for the first time you have to give the data. From there, you have to make a model by writing the code. After you make the model, you will get an output. Second time, when you give the data, your model will work for you. You don't need to write the code, right? Your model is ready, and now it can like automatically evaluate your data and give you the prediction. So this is how machine learning works, and this is how it's different from traditional programming. Now, if we look at the what is machine learning, if you look at the image itself, you can see input raw data. You have apple, banana, mango, and you give this to some algorithm, and our algorithm makes a model out of it, right? And then your model will be in a training phase, and lastly, it will identify this is apple, this is mango, and this is banana. Right? So this is the process to train a machine learning model. Now we will have a look at what is the life cycle of building a model with machine learning. So here there is the steps. But before that, I just want to give you a proper practical implementation for that you can understand how this machine learning works. So what they are saying for the first one, they said understand the business problem. What is a business problem? Maybe you have hired as a data scientist in the Swiggy. So Swiggy or Zomato, as a food industry companies, they actually try to focus their business, and if they actually want to understand what are the restaurants are doing good, what are the restaurant they can give for the discounts to the customers for that their sales will be in high position. So in this case, what they have done, they give you the data, and as a data scientist, you have to understand the objectives. If you don't, if you are not clear with the objective, you cannot solve it, right? So first you have to understand the business problem. After you understand the business problem, you have to go for data acquisitions. So what is data acquisition? Data acquisition is nothing but a data collection. You have to collect your data. So you will ask, maybe the company is going to give me data. Why do we need to collect the data? The more data you have, the more possibility you have, right? So whenever you have chance to collect the data, why don't you go for collecting the data? Because you will get new patterns, you will get new ideas to train your model. So data acquisition is also one of the most important part. Then comes data cleaning. So data cleaning, you can say, according to me, it's the most time consuming part. You will ask me why data cleaning is the most consuming part and most important part. So when you have understanding of business, when you have the data, but data in an unstructured way, trust me, your data is useless. So if you want to make your data useful, that time you have to go for data cleaning. There are lots of things that, like maybe misspelled attribute you will have lots of columns that are not in use, you will get lots of error in the spelling in the data, right? So there are lots of things you will get in data, and you have to sort them out. You have to understand what are the columns you really need to do this, prediction. So in this case, data cleaning, or rather it's known as data processing, is one of the most used phase. Then comes exploratory data analysis. As we all know, being a data scientist or being a machine learning engineer, you need to have few pillars. What are those pillars? You need to have a basic understanding of the mathematics, you need to have a basic understanding of the programming, and also the basic understanding of linear algebra. So now if we talked about the exploratory data analysis, here what we have done, we actually use some statistical concepts to understand our data, to describe our data. So after you clean your data, if you just go for exploratory data analysis, and if you do some data visualization technique, maybe you can find it out there are few missing value you have, or there are few outliers you have. We will talk in the later what are the outlier we have talking about. So yes, there are lots of things you can understand about your data. After there will be a machine learning algorithm. So when your data is clean, you have a good idea about your data, you can go for using one of the algorithm from machine learning. So from the machine learning, if you go for choosing the algorithm, for that you need to have a good understanding of your data. Your data is a labeled data or unlabeled data. We will talk about that. So after you choose your machine learning algorithm, you can start train your model. After train your model, you have to give a new data to your model to predict it, right? And lastly, when you say with the new data as well, your model is working perfectly fine, you can deploy your model for that others can start using your model. So this is the full life cycle to build a model with machine learning. Now we will have a look at what the types of machine learning we have. We have supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning? Supervised learning is nothing but when you have a supervisor itself. So you have a labeled data, that time you can go for supervised learning. When you don't have a supervisor or an unlabeled data, that time your model will start learning by itself by clustering the data, which is known as unsupervised learning. And also lastly, we have reinforcement learning. Let me give you an example of reinforcement learning. So basically when we talk about, suppose, Tesla self-driving car, which is known as reinforcement learning application. So what reinforcement learning does, when your model works perfectly fine, it will give you a reward. But when your model is going to work not perfectly, that time it's going to give you a penalty. That's why this reinforcement learning is known for self-driving car and other applications. So these are the type of machine learning we have in our machine learning. Now we are going to talk about what is supervised learning. Supervised learning works as a supervisor or teacher, as we have talked in the last part. So here we are going to go deep and try to understand how this supervised learning actually works. So basically in supervised learning, we teach or train the machine with labeled data. That means the data is already tagged with some predefined class. I will take a data set and I will show you how this supervised labeling works for the data set. right? Then we test our model with some unknown new set of data and predict the level of them, right? So let's go to one particular raw data and let's have a look at what level we are actually talking about. Right. Suppose if you look over here, we have a data set for credit card fraud analysis. That's one of the project we are going to do. Now, if you just look at the data set, can you see we have columns? So you can see we have time column V1, V2, V3, and all of them. Or maybe I can show one more data set. Like first look at here, and then we will see the diabetes data set as well to understand this particular labeling, right? So here you can see we have V28 amount and lastly we have class. So these are all the time V1, V2 till V28 will be your dependent variable, amount will be your dependent variable, but the class is what? Class is 0 and 1. So if your data is perfect, if your transaction is good, then it's a genuine transaction. If there something wrong, then that will be fraud transaction. So fraud transaction denotes as 1 and genuine transaction denotes as 0. So this 0 and 1 is nothing but your supervisor. So basically you have lots of independent variables and this dependent variable, it's going to train your model. Hey, these are the dependent variables I have. According to that, the answer is this. So this is where we can see this particular column is nothing but your supervisor. Now, if we look at one more data sets, maybe let me just open it. Okay. Right. So now if you can look at here, we have one more data set that is called as diabetes data set. Here we have some dependent variable and also independent variable. So this data set we are going to use to predict that particular person has like diabetes or not. So you can see we have pregnancy column, we have glucose, we have blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, then we have age and the outcome. So if you look at, let me just make it little bold to make you understand. Right. Here it will be white. Let me just make it bold. Okay. So if you look over here, you can see we have this dependent column and this is the independent column. So if you can look at this, outcome will be your supervisor in the case of supervised learning. Starting with machine learning, you have to have a good idea about data set, right? So if you have a label data set like this, then you should use supervised learning. Suppose in a data set, you don't have this particular label, that is the data set without any labeling. So that time you have to use unsupervised models, right? So this is where we have come with outcome. So here you can see this outcome is nothing but your supervisor for your model, right? I hope you understand how this supervised learning works. Let's go back to the presentation. Yeah. So you can see the learning from the label data and applying the knowledge to predict the level of the new data, that you have to give all the dependent variables, and when we are going to use the predict portion, we will not give that outcome column, right? So that is known as supervised learning. So we have two types of supervised learning. One is regression, one is classification. So now let's have a look at what is regression. Right. No, first we will talk about classification and then we will talk about regression. Right? So classification is the process of grouping similar data points. So if you have the same type of data points, that time you have to group it together. This is known as classification. So as we have taken down two different, example one is classification for, this is the classification data set. Again, go back to here. So this particular diabetes data set is a classification data set. Why? You are classifying your data, maybe that particular person is diabetic or not, according to or depending to other variables. So this is how you can say, okay, this is my classification or categorical data set. So classification is the process of grouping similar data points. Now, if you just look at the regression, right? So I don't have any data set with me right now, which is a regression data set, but you can understand the regression is like you will have a labeled data, but the data will be in a continuous way. Suppose the weight of a person, right? Or suppose maybe we will talk about the weather. What is the weather or what is the temperature? right? So these are the things is nothing but the regression. So for the classification itself, we can say what will be the weather for tomorrow, rainy or sunny. The predicts categorical outcome. So maybe the weather will be rainy or the weather will be sunny. So there is two class you have. But in the case of regression, predicts a continuous outcome. So what is the temperature forecasting for tomorrow? Right? So we are going to forecast the temperature. Temperature can be 94.7, 28.8, right? Anything. So this is nothing but your continuous value. So this is the difference between classification and regression, right? Now, as we have talked about what is classification, we have talked about what is regression. Now we will see what are the types of classification algorithm we have under machine learning. So first algorithm we have, that is logistic regression. We have decision tree, we have random forest, k-nearest neighbor, and naive Bayes. In this particular part, we are going to talk about naive Bayes and logistic regression, right? So yes, we have talked about in this part what are the, what is machine learning. We have talked about what is supervised learning. We see some of the data sets to understand that what is the level we have in data, and what is regression and classification, and what are the types of classification algorithms we have in our machine learning concepts, right? In this part, we are going to talk about the logistic regression. That is also comes under one of the supervised learning technique in machine learning, which used for classification algorithm. Now let's have a look at what is logistic regression. Logistic regression is also a part of supervised learning classification algorithm that we already know. It is used to predict the probability of a target variable. Yes, it's basically used to predict the probability of a target variable, and the nature of a target or a dependent variable is discrete. So for the output, there will be only two class will be present. As we have talked about the data set of diabetes data set, so we need to try to find it out the particular person is diabetic or not, depending upon the other dependent variable. The dependent variable is binary in nature, so that can be either 1 or 0, yes or no, true or negative, right? So this is how you can understand that this will be only two class we will have. The logistic regression is also known as sigmoid function. We have a function called sigmoid function, and we use this particular concepts in logistic regression. The formula for the sigmoid function we know, that is 1 by 1 plus to the power minus value. Now, if we talk about how actually logistic regressions comes into the picture, and if we just go back a little bit and we just try to understand the linear regression. So in the case of linear regression, as it's a regression and it's a continuous value we use for that, we use a one particular formula that for that y equals to mx plus c, the straight line formula. So in this case, if we just put that particular formula for this, the case of the finding out the size of the cat, so we know the size of the cat is 2.1 into weight plus 4. So maybe if we just write weight equals to 0, then also the predicted size for that cat equals to 4. Is it really possible the particular cat has a 0 weight but the size is 4 inches? No, right? How is it possible? That there where actually linear regression fails and the logistic regressions comes into the picture. So we can see the logistic regression is similar to linear regression, except it predicts whether something is true or false instead of predicting something continuous like size of cat, right? So here you can see the probability of cat is obese, and the probability of that the cat is not obese is there. Right? So there you can see this is the probability of cat is obese and this is the probability of cat is not obese. Right? So here we are just going to predict yes or no, true or false. And this is where logistic regressions comes into the picture. So if you can see, if you get your point and probability near to 1, we can see there is a high probability of the new cat of being obese. And if you get the probability near to 0, you can say there is a high probability that the particular cat is not being obese. Right? The curve tells the probability of the cat being an obese based on its weight. So this is the S curve. This is known as the S curve. Basically, we use in logistic regression. Right? So this is like little bit about logistic regression. So if you get your point near to not 0.5 and 0.5.5, there is a 50% chance that the cat is obese and that cat is not obese. The curve tells the probability of the cat of being obese and based on its weight, right? So this is how this logistic regression work. So if you get the point is near about to zero, the very low probability of the light cat being an obese. So it's generally used for classification. For example, if the probability of a cat being obese is greater than 50%, we use a threshold value. So if we see the probability of the like you get the probability which is greater than 50%, then it is classified as obese. And if it is less than 50%, then it will be classified as not obese, right? So this is how our the logistic regression works. Now if we just look at the mathematical explanation of logistic regression, from where this logistic regression comes. So logistic regression is a special case of linear regression, we can say. So we know for linear regression we use a formula that is y equals to mx plus c, and in the more data points we use y equals to m1 x1 plus m2 x2 plus dot 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 and so on, where we are going to use a function in logistic regression that is p equals to 1 by 1 plus to the power minus y. This is nothing but your sigmoid function. Now if you just replace your m1, just p, what we have basically here, if you can look over here, so if you just have e to the power minus y, so if you just replace your minus y equals to m1 x1 plus m2 x2 dot 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 and so on, you can see you will get the formula of logistic regression. So this is nothing but related to linear regression, but here we use classification. So we do yes or no, true or false, obese or not obese, and so on. So this is something about logistic regression we learned, right? So if you just want to check the real-time use cases that come under logistic regression problem, maybe you just need to, will that property have a good neighborhood? Maybe that property have a good neighborhood, maybe not. Is this mail is a spam mail or not, right? So these are the things you can understand by using logistic regression algorithm. Now we will talk about the few key points we have in logistic regression. That is, it's a categorical variable, solve classification issues, not the continuous value problems. It has a S-curve, and it is like the example of it is the mail is particularly spam or not. So yes, this is all about logistic regression we have learned so far, the mathematical explanation of logistic regression, why logistic regression comes into the picture, and what are the key points we have in logistic regression. Now we are going to do a project on logistic regression, that is credit card fraud analysis using this particular algorithm. And we will see that particular transaction is a fraud transaction or is a genuine transaction. Part, we are going to talk about credit card fraud analysis using logistic regression. In this part, we are going to do an end-to-end project using logistic regression to find a transaction is a fraud transaction or not, right? So in this case, we are going to use a data set from Kaggle itself, and we have uploaded this data set to Dropbox. Now, if I just want to show you the data set, so in this case, let me just show you what we have in the data set. But before start with the data set, we just need to understand that what are the things we have in the data set. So always look into the raw data to have a good understanding of your data, right? It's too big. Let me just download it. Okay. Right. So here it's not getting downloaded, but it's already there in my local system itself. So if I go here and let me just write credit card, right? Let me just open the dataset to make you understand what we have in the dataset itself, because we have talked about we have few types of datasets. One is continuous type dataset. Your dependent variable will be continuous type. One will be your dataset will be categorical dataset. So you have classes. So here we will have two classes. One is the transaction is a fraud transaction or the transaction is a normal transaction. So it's a big file. It's a big CSV file, that is comma separated file. So it is taking little time. So when it's going to be open, and I will show you what are the columns we have in our dataset. Basically in the dataset, we need to check few parts, that is dependent variable, independent variables, and what is the type of your dataset. So this, your dependent variable is a continuous type or your dependent variable is a categorical type, right? So in this case, our data will be categorical as we will have two class, right? So it's almost 92% yes. So if you just look at the data set, you can see we have time column, then we have V1, V2 and so on. And lastly, we will have amount column and then we will have class column. So the amount is nothing but the what is the amount of the transaction you have done, and class is 0. Basically this is a genuine transaction. If the class is 1, do we have anything 1? If we have 1, then the transaction is a fraud transaction, right? Let me just check. Do we have, did we just missed one? Okay, so if we have 1, so that means that transaction is nothing but the fraud transaction. Let me just check more. No, I don't get it right away, but it's fine. So let's go to Anaconda and not Anaconda. Let's go to Google Colab and let's have a look at how to go with the dataset, right? So I have just uploaded the dataset to Dropbox, and there you will get this shareable link. And in the shareable link, you can use in the Google Colab itself. Now, if you just look at what are the libraries we have imported NumPy, Pandas, Matplotlib, then matplotlib.pyplot. This is .pyplot is nothing but it's a MATLAB, right? You can directly use the MATLAB function. So this is why we use .pyplot. Then we have model selection, that train trace split from scikit-learn to split your dataset. Then we have classification report just to check what is the report accuracy. Then you have confusion matrix. We will talk about what is confusion matrix. Then we have import the logistic regression, as we are going to use logistic regression. And from there we have matrix and Seaborn, right? Seaborn is also a data visualization library, right? So this is the dataset link, right, from the Kaggle itself. If you just click on here, you will just redirect it to Kaggle website itself. It's a open source data. Anyone can use it, right? So this is all about the data, right? You can see this is the dataset, right? So you can directly download it from Kaggle itself. Just click on download, your dataset will be downloaded. Now, if you don't want to upload your dataset into Dropbox, then how to upload directly? Here is a box sign you can see. Click over here. Here you will get an upload option. Just click over here. It will redirect to your local system wherever you will have the the dataset. Just suppose technical support data I have, just click over here and then open. It will automatically upload the dataset, right? Let me just do that. Right, so you can see your data is already here, but be sure this data, whatever the data you have uploading in Google Colab, it will stay for only 12 hours. After that, it will be recycled, right? So whatever the work you are going to do in Google Colab, make sure that you have downloaded. Right, now we need to use the .read CSV function from Pandas. So .read CSV function, how it works, it's nothing but it's going to read the comma separated values, right? So in this case, you have to give the path for your dataset. But wait, from where we will get the path? We have just uploaded the dataset. So here you can do one thing. If you just hover over this dataset you have, and you will get 3 points over here. Just click over here, you will get the option for download. If you want to delete the file, delete. Then rename if you want to rename the file, and copy path. So if you just copy the path and if you just put the path over here, it will automatically read the .csv file. Right? It's automatically reads. Right now, if we talk about the dataset, it contains 285000 rows and of the data and 31 columns we have. The most important columns are time, amount, and the class, that is fraud or not fraud, right? And if your class is equals to 0, it's not a fraud transaction, it's a genuine transaction. If your class equals to 1, it's a fraud transaction. Now, if we just want to see the first 5 rows of our data set, how to do that? You just need to use data.df, where we have actually, if you can look at the variable, we have stored our CSV file, that is data.df. And if you just write data.df.head, you will get the first 5 rows of your data, right? Can you see time, v1, v2, v3, v4, and so on, and amount and class, right? You have. Now, if you want to check the shape of your data, how to do that? You just need to write data.df.shape function. It's going to return you how many rows you have, how many columns you have. So we have total 284807 rows and 31 columns. Right, now if you want to check the describe, so where to use describe? And one more thing I want to show you, if you want to check the columns, so data.column. So basically it will return you what are the columns name you have in your data set. sorry, it will be data df, right? So what are the columns you have in your data set? So these are the 31 columns I have in my data set, right? Now if you want to check the describe, so describe is nothing but it's going to return you some statistical information about your data set. So particularly for this 3 columns, I want to check the statistical information of my data set. So in this case, I have written amount, time and class, right? Can you see the list I'm providing here? And then we have using dot describe function. So if I just click over here and just execute it, you can see we have total count of the data, you have the rows, then you have the mean value, right? What is the mean of your total column? Then you have standard deviation, then you have minimum amount you have in your data. Then we have IQR, that is interquartile range. So interquartile range, if you want, if you just divide your data set in 4 different parts, first quantile, second quantile and third quantile and so on. So this is 25%, 50%, 70% and max. So this is all you will get about if you just use dot describe function, right? Now it's this columns is already done. Now we are going to check, is there any missing value do we have in our data set? As we have talked in that as well, this missing value, if you have missing value in your data set, it's not going to provide a good prediction for your data. It's always give you some arbitrary predictions, and it's also not perform well, right? So in this case, make sure that your data does not have the type of the missing value will be really less, right? So in that case, to check with missing value, what we need to do, we need to use one function that is called dot isany function. Let me just cut this part, right? If I just use data df dot isany, that time you can see it's going to provide me for each and every rows and columns, right? Maybe for each and every index itself, it's going to give you, is there any null value is there or not. But looking at this like this, it's not possible to, you can see the most of the cases is false, but maybe there is a true, maybe you will not able to find it out. That time we are going to use a function called dot any. So dot any function, what does this dot any function? It's going to check for each and every column, is there any null value is there or not. Is there any null value, it's going to return you true, otherwise it's going to return you false. Normally it returns the boolean values. For time there is false, for all the cases you can see there is false, so we can say there is no missing value. Now if you want to again reconfirm it, we have done a manual job, right? So what we have done, we have used the columns, and we have actually making a data frame here. Here we have columns, that data df dot isany dot sum. Is there any that what is the sum of the dot, null functions we have, or not the null function, not the null value basically we have. Then we have if you have then dot index, then number of null values, right? So what is the number of null values you have, then values, then percentage. So basically we want to check what is the percentage of the null value we have. Now if we just print it, so what we will get columns, the column name, we have the number of null values, that is 0, and lastly we have percentage. What is the percentage of null value we have? So here you can see this is all as 0, right? So we can say the null value percentage is 0 for this particular data set. But normally for the real time cases, you will not get a data which has 0 null value. So always you have to try to understand how to find it out, the null values and the missing values as well. So now if you want to check the last 10 rows of your data from the class itself, you just need to use dot tail function. Can you see? We got it. Now we are going to check the percentage of total number of fraud transaction. And what is the percentage of genuine transaction you have in your data set? So for that, what we have done, we take a variable called nif count, and this is equals to 0 because it will work as a counter, right? Now what we have done, we have written not fraud equals to data df, and then you want class, okay? So whenever, let me just add one cell over here. So whenever we try to get particular cell, like a particular column from your data set, that time what we have done, so we try to take the particular column name, right? So for my case, I am going to take class, right? So you can see what it actually have. This class is nothing but your outcome, and it is a dependent variable or on other columns you have. And in here you can see it's not fraud equals to, we take the whole class, right? So now what we are actually trying to do, we will try to count all the one, right? It's not fraud. So basically we will try to count all the zero, like how much zero you have in the particular column, and divide it by the total number of records you have into 100. So that's how we can actually understand the percentage of genuine transaction in your data set. So in this case, what we have done, you can see not fraud equals to data df class. Now we have used a for loop and we have written that for I in range length of not fraud. So it will go the length of not fraud. Like for this, you can, if you want to see what is that, let me just write it over here. So not fraud, right? If we can do this two particular place over here, and if we just write one more code cell, let me just execute that. Now what we are going to do, we are going to say not fraud, okay? And here we have used length function, right? So you will get nothing but the length of the not fraud. So total number of rows you have in your data set. So you can see this is 284807. Right? So now what we have done over here, we actually, your for loop will walk till this part, right? And if said, if not fraud of I, not fraud of I is basically the value you have, not the index number, 0 or 1. So not fraud of I equals to 0. If it's equals to 0, then please increase the counter. My counter is nf count over here 0. It will count 1 plus 1 plus 1, right? Then what we have done that the percentage. So you got that nf count, right? Here you got the nf count. So now you know how much, like if I just write here after this, if I just, okay, let me just break it in few parts for that you can understand what actually we are trying to do. So here, right. So in this nf count will have all the count of 0 you have in your data set. So you can see 284315 records you have, they are 0. Basically, they are the genuine transaction. Now what I have done, I just want to understand the percentage. So nf count divided by total number of records you have into 100. So for that you will get the percentage of total not fraud transaction or the genuine transaction. So 99.82% of data set you have, that is a genuine transaction. Now we will count the fraud transaction in the same way. Again we will take a counter over here. From there you can see the fraud equals to, we take the class again, and what we are doing, we are writing fraud of I equals to 1. So we will try to understand how much like data or rows we have with class 1, right? So that basically nothing but your fraud transaction. Okay, so let me just do this as well. Right, so in this case you will get the if count 492, right? It's a very negligible, but yeah, there are fraud transaction you have in your data set. So now if we just try to find it out the percentage, so it's nothing but 0.1%. Right? So this is how we have understood that what is the percentage of genuine transaction you have in your data set and what is the percentage of fraud transaction you have in your data set. Now, if you just need to plot it, right? How to do that? In this case, you have written plot data equals to pd.data frame. You have created a empty data frame over here. Now you have written plot data fraud transaction equals to fraud. So the fraud you had, right? Now you just give plot data genuine transaction, right? Genuine transaction equals to not fraud. Then plot the data. So here what we have done, if you can look over here, right? So not fraud, it will become your if count. And this will be less, I think, right? And it will be nf count if I'm not wrong, but it's, yeah, right. So here you can see one thing, your fraud transaction will be, so you basically try to understand your fraud transaction and your genuine transaction, right? So in this case, what you have done, if we just remove this two part, right? Let me just do that. And let me just write plot.height. So basically you can do it, otherwise you can skip it as well. That's not the problem. Plot data. No, it's not coming. Why? Acha, okay. Fine. Why it's not coming? Because this F count is nothing but your total number, right? And this is how basically you can skip this part. There is no point of using. But yeah, if you want to make a data frame out of it, or if you just write the transactions, maybe you can write the transactions and you can use the data df class, right? Now, if you just try to print it, you can see the only like the class column you will have in this particular data frame. Now, what we need to do, we try to understand and visualize our data. How to visualize our data? We try to understand that what are the data are actually going to help us to understand what is the bar plot. We actually do bar plot to understand visually that what we have done, the calculation that is right or wrong. So in this case, what we are going to do, we are going to write plt dot, you can say plt dot title bar plot for fraud versus genuine transaction, right? So you can use bar plot or you can use count plot as well, right? So you can see what we have done. We have written x equals to fraud transaction, y equals to genuine transactions, right? And what we need to do, we basically try to give the data set over here. So here you can see what we have done. We were working with that bar plot, but now I want to have a count plot, right? So count plot over here will work as like, it will automatically count. Otherwise, you need to do all the count by yourself. So in this case, what we have done, we have written plt dot title count plot for fraud versus genuine transaction, right? So now for 0 is genuine and 1 is fraud transaction. So if you just write SNS from cbond, basically if you write SNS dot count plot, you can see this is the all about count plot. Show the count of observation in each categorical bin using bars. So you have two bin over here, 0 and 1, and a count plot can be thought of as a histogram across the categorical instead of quantitative variable. The basic API and options are identical to those for bar plot, so you can compare counts across nested variables. Input data can be passed in variety of formats and including the vectors data represented. At least there is no point of understanding this, but now you can understand. It will automatically count how many 0 you have in your data set, how many 1 you have in your data set. So what I have I have written that x equals to class, then data equals to data df, your data set, then palette equals to blues, I want the blue, and then age color equals to w, right? So you can see for in this case, whenever I try to execute it, for that you can see the 0 is the high, 1 is almost negligible, right? So you can see and you can say, okay, whatever the percentage we have, find it out, it's quite right, because in the bar graph in the count plot itself is showing the same, right? So as for the graph, we can see the ratio of genuine transactions and higher than the fraud transaction, right? So now if you want to check the plot, normal plot, how to do, you just need to write maybe for the x and the y, I just want to check between amount and time. So in this case, I have written data df amount and y equals to data df time, and then I have written plt dot plot xy, and the title will be plt dot title time versus amount. Right. So in this case, you can see this is the relation between amount and time. And this graph, we try to plot the relationship between time and amount. You can see this is the time and this is the amount. Right. X equals to, X equals to amount. So these are the 5,000, 10,000 to 15,000 is your amount, and this is your time, right? How much time it takes to do the transaction. Now, if we just try to understand the amount distribution, where the amount is high, where the amount is what is the distribution of your amount you have in your data set, that time again we are going to use this plot, right? So this plot is kind of a histogram type of a thing, you can say. So here we are going to try to do the amount distribution. So in the amount distribution, what we need to do, we try to understand the distribution of the amount in our data set. So here we are going to use cbond displot. So you can see we have taken only the amount column. Now, what we have done, color equals to red. I just want the distribution should be looks in red. So in this case, if you look over this, you can check, you can see from the amount distribution curve, it's shown that the number of higher transactions are very low. Obviously, so you can see this is the high transaction are really low. Most of them are in between 5,000, right? And so there is a high probability for huge transaction to be fraud, right? So this is the high. If you see there is a 25,000 and more like amount is high, so at that time there is a chance that your transaction is a fraud transaction, right? So now we will talk about the outlier. So for outlier we can use box plot and we can use scatter plot as well. So we try to understand, because of this problem we need outliers, because those transaction in a high amount, that time there is a chance that these are the outliers, and these are the cases where we need to find it out that okay, these are the cases for my transaction can be fraud, right? So in this case we try to use scatter plot. So that dot scatter, if you just call dot scatter and if you just give it your your scatter plot will be plotted using your data set. You can see this 25,000 only one dot here. So these are your data points. Most of the data points are from 0 to 5,000, and after 10,000 also you have, but after 10,000 all of our is your actually outlier, right? So in this case we need outlier to understand the fraud transactions behavior. And now if we talk about the correlation matrix, yes, there is a concept of correlation to understand the correlation between two different variable you have in your data set. So in this case correlation matrix equals to data df dot core if you write, and if you just plot it with the figure size I have given 14,9, and if you just write a cbond dot heat map, it's nothing but it's going to give you the correlation between two different variable for time and time. You can see it's you can say this is quite white. So this is the color range is also here. When it's quite white type of a thing, it's the high correlated. When it's near to black or blue and something like that, it's the correlation is low, right? So this is how you can understand the correlation between two different variable you have in your data set. So correlation matrix helps us to understand the correlation between two attributes, right? So now, yeah, it's pretty much about the data set. We have done the outlier analysis. We try to understand our data. We try to understand the fraud transactions. Now what we need to do, we just need to split our data for machine learning. So splitting our data is nothing but you can split your data at 80 and 20% or maybe 70-30%. It's up to you. So 80% for training, 20% for testing. So when you do that model training, that time your model will not see your testing data. So it will be a new data for your model, right? So for that, you can see for x equals to df, data df dot drop. So we try to have all the features in x, and the outcome column, the class column, the dependent column for others will be stored in y, right? After that, what we have done, we use scikit-learn to split our data. We have used we actually split our data in 4 different parts: x train, x test, where you will have all the features; y train, y test will have the class, right? And train test split function you have to call, and then you need to pass your x and y. Then you have written test size equals to 0.2, that is nothing but 80 and 20%. If you write 0.3, it's nothing but 70% and 30%, right? And random state equals to 42, because we try to say that there is no hard and fast rule that first 80% will be for testing, will be for training, and 20% for training testing, right? So it's like randomly it will take the data and it will just make your testing and training data set, right? So yeah, it's pretty much about the x train, y train. Now if you just want to check the shape of x train, you can write x train dot shape. Right, what you get this 2, 2, 7, 8, 4, 5, 30, right? And if you just do the x test, you can check your shape like this. I will get an error. Okay, right, for testing you can see 5, 6, 9, 6, 2, and this is 30, right? So this is how your x train, x test, y train, y test works. Now if we are going to use logistic regression, we talked about logistic regression. For scikit-learn, what you need to do, you just need to call the function, right? Because there are a lot of all the you can say all the machine learning algorithm are already implemented in scikit-learn. So what we need to do, we just need to call logistic regression function, and you can see this is the logistic regression function we have called. Now if you want to train your model, you just need to call dot fit function, and you will provide x train and y train, right? Let me do that. Now, if you want to check what is the prediction for your model, that time what you need to do, you have to use dot predict function. And this time you are going to give your only the features, and we will try to find it out what? The class, right? So whenever you try to use ypred, and we are going to give the logistic regression dot predict x test, and if we just code here ypred, right? So here we will get all the class 1 0 0 0 0 0. So now if we try to understand the accuracy, we need to call one more function, that is logistic regression dot score, and you have to pass x test and y test, right? So now if we just try to understand what is the accuracy, let me just print it. So accuracy is 99.85%. So yeah, your model is working pretty cool and pretty fine. And if you want to add few other things, you can, right? And one more thing, I just want to explain that what is confusion matrix. So whatever the accuracy we have done over here, there is one more concept from those matrix as well, you can find it out. So in this case, we called confusion matrix. In confusion matrix, we have few parameters. That's positive, negative, true positive, false positive, true negative, false negative, right? So what is positive? Observation is positive. For example, the transaction is true. Then observation is not positive. For example, the transaction is not genuine. Then we have term called true positive. What is true positive? The observation is positive and is predicted to be positive. That is true positive. So both the cases is positive. Now comes false positive. So here you can see observation is basically negative. The predicted value is positive. Then your model is not perfect, like working well. Now comes false negative. So observation is positive, but your predicted is negative. Again, your model is not working fine. Then comes true negative, when the observation is also negative and the predicted is also negative. So when you're have more true positive and true negative, your model is actually working quite fine, because what your model is quite understanding with the new data that whatever it needs to be done, right? So the formula for accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative, right? So this is known as confusion matrix. And if you want to do this confusion matrix, if you want to check the confusion matrix, you need to write, and you also again need to import matrix, and after importing matrix, you need to call dot confusion matrix function, and you have to give y test, that actual class, and then ypred, that is actually predicted by your model. Now if you can look over here, this is your confusion matrix. And if you want to do the calculation of accuracy the same way, and you will get that 99.85% accuracy. With this percent of accuracy, your model is saying whatever you have done, it's right, right? So this is how we can actually start working with logistic regression. And I hope you understand that how can you start working with your new project on logistic regression. In this video, we are going to talk about naive Bayes classification. So let's have a look at what is naive Bayes classification, which comes under supervised learning, right? It's one of the algorithm which is supervised learning in machine learning. So let's see what is naive Bayes. Right. So naive Bayes classifiers are belonging from a simple probabilistic classifier based on Bayes theorem. Yes. So if you know Bayes theorem, naive Bayes is one of the most easiest things for you. So here, what actually naive Bayes said, the probability of A given B, when you know the B for probability A equals to probability of B given A of probability of A divided by probability of B. So what is probability of B given A? Probability of B given A equals to probability of B being true given that A is true. What is probability of A? Probability of A being true. And what is probability of B? Probability of B of basically probability of B being true, right? So this is actually you can see the naive Bayes claims. Now if you look further, so we will have a look at what is a naive Bayes algorithm. So naive Bayes classifiers assumes that the presence of a particular feature in a class is unrelated or independent to the presence of any other features, right? So they actually takes very naive assumptions, right? So that's why it's known as naive Bayes algorithm as well. So you can see in this case, they're saying that presence of a particular features is not dependent, or it's like you can say independent or unrelated to each other, right? For example, the apple color is red, shape is round, and diameter is 3 inches. So they will say this color, shape, and diameter will not dependent to any other, right? So they are independent to each other, right? So this is actually what is a naive Bayes algorithm. Now, if we look at why is naive Bayes algorithms are called so. So in this case, why was the algorithm naive named as naive? So assumptions are taken by the algorithms are very naive, right? There are very naive assumption is taken by the algorithm. Those assumptions may or may not be correct. So this is the flaws in this particular algorithm, that all the assumptions is taken by naive, like taken by the naive Bayes theorem, or the algorithm is not right always. So after that, why the algorithm has the word Bayes in it? Because fundamentals are based on the Bayes theorem, right? So these are the main understanding of why this is called as naive Bayes. Naive Bayes is because it's a Bayes theorem, and naive is basically they take some naive assumption when they go for doing the classification, right? So this is why it's known as naive Bayes algorithm. Now if we look at the example of Bayes theorem, so there is a example or a scenario. We can say, what is the probability that your flight will be on time today, given that, right, there is a condition given that the weather is sunny or humidity is low, right? So what is the question you have? You have, what is the probability that your flight will be on time today, given that the weather is sunny and humidity is low? So these are the two conditions you have. According to that, you have to find it out what is the probability for you to like your flight will be on time. So this is the example of Bayes theorem. Now if we look at the Bayes theorem, another example, finding the probability of having a disease given you were tested positive. So when you know that you are tested positive, and what is the probability of having the disease? So this is also an example of Bayes theorem. Then we will have a look at the conditional probability. Why? Because in Bayes theorem we do use conditional probability. So what is conditional probability? Maybe you are going to define two events. Those two events are related to each other. Event A is the probability of the event we are trying to calculate. Event B is the condition that we know, or the event that has happened. So basically, for event A, you are trying to calculate when you know when the event B is already done, right? So that time this conditional probability is known as probability of A given B. So you know what is B already has happened, and you need to try to find it out, the calculating the probability of A. The probability of occurrence of event A given that B has already happened. So probability of A given B equals to probability of A and B divided by probability of B. So probability of the occurrence of the both A and B divided by probability B. This is known as conditional probability. So in the conditional probability, there is two parts when you try to find it out one particular probability when you know the other condition, right? So this is known as conditional probability. So if we take an understanding of conditional probability, like an example, probability of getting 1 by rolling a dice given your event B, after roll the dice, it is an odd number. So you know the dice, when you roll the dice, after that you get an odd number. But what is the probability from that odd number? It will be 1, right? So your solution will be event A equals to getting 1 by the rolling the dice, and event B that you know that is it's an odd number. So probability of A equals to 1 by 6, right? So 6 parts you have in the dice, right? And after given the condition, the probability of getting an odd dice will be what? 1, 3, 5, right? That equals to 3. Total number equals to 3, because 2, 4, 6 will not be an odd number. It will be an even number. That's why your probability of A given B equals to 1 by 3. Otherwise, if you don't give that, what is the probability? Like if you don't give this particular event that the dice is already odd number, then the probability will become 1 by 6. But as we are using a conditional probability, when we have actually mentioned about even b, which is that already rolled dice is a odd number, that time the probability of getting an old dice equals to 1/3. Right? So this is the understanding of conditional probability. Now, if we try to understand the Bayes theorem describes the probability of an event based on the prior knowledge of the conditions that might be related to the event. In simple words, Bayes theorem shows the relation between a conditional probability and its reverse form. If conditional probability equals to PA given B, which is probability of A given B, you can use Bayes rule to find the reverse probability of B given A. Right? So this is pretty much about Bayes theorem, and why we called this particular algorithm as a naive Bayes algorithm. So if we look at the explanation of Bayes theorem, you can say P, that probability of A given B equals to probability of B given A, which is the prior what you believed before you saw the evidence, and then probability of A, this is the likelihood of seeing that evidence if your hypothesis is correct, and probability of B, this is the likelihood of the evidence under any circumstances, right? And probability of A given B will be your posterior, right? So this is the explanation of Bayes theorem. So if we take the example of Bayes theorem, find out the probability of having liver disease if the patient is an alcoholic. So you are trying to understand the probability of A, that your event A, which will be probability of having liver disease, and your event B will be the patient is an alcoholic. So when it's given that the patient is an alcoholic, what is the probability of the having a liver disease, right? So this is what the Bayes theorem example stands for or looks like. Now, if you just look at the summarizing the data set, suppose flight will on time or not. So in this case, you have total rows, total sample equals to 14. Number of attributes is nothing but your columns equals to 4, and number of class 1. Right? So total yes is P of probability of yes equals to 9 by 14, and total no equals to 5 by 14. So basically it's a common data set you can take to finding out that flight will be on time or not, given that the temperature, humidity and windy. Right? So this is how we actually use naive Bayes theorem. And after this, as we have learned about the theoretical part, we are going to do a project on naive Bayes using diabetes prediction using naive Bayes. So we will have a data set where we are going to talk about the diabetes, and from there we will try to find it out a person is what is the probability of being diabetic. Right? So let's see how we will do this particular project. In this part, we are going to do this diabetic prediction on PIMA Indian diabetes dataset using naive Bayes. But before start with this, we will have a look at about the database. Right? So let's go to this particular link. We will get this dataset from Google. This is open source and anyone can use this. So if you click over here, it will redirect you to PIMA Indian diabetes dataset. So let's have a look at what are the things we have in the dataset before do the prediction using naive Bayes. So here, if you can look at, you will get the dataset, that PIMA Indian dataset. If you want to download it, you just click on to download. It will automatically start downloading your dataset. And if you want to see the context of the dataset is originally from National Institute of Diabetes and Digestive and Kidney Disease. The objective of the dataset to diagnostic predict whether or not a patient has diabetes based on certain diagnostics measurements included in the dataset. Several constraints were placed on the selection of the instances from the larger diabetes. In particular, all the patients here are females at least 21 years old of PIMA Indian heritage. Right? This is the context of the dataset. I mean, on the basis of what are the things that we can predict that particular person has dataset or not. And also, this PIMA Indian dataset is basically has total 9 columns. So first we will have a look at the dataset, and from there we will see what are the predictors we have and what are the dependent and independent variables we have. right? So whenever we are going to use any classification technique, as we talk, that the data set should be categorical data set, right? And let's have a look at what are the columns we have. So first we have pregnancies, so it will denote that number of times the patient got pregnant. Then glucose, the plasma glucose concentration, that's obvious. Then blood pressure, the diabetic blood pressure. Then we will see about skin thickness, the tricep skin fold thickness, that actually depends on the diabetes as well. Then insulin, and then we will talk about body mass index, then diabetes pedigree function, and then we will have a look at age. Then whatever the column we have talked about still so far, according to that we will have an outcome column. This outcome column is nothing but it's going to provide us the information based on these particular columns and those attributes, this person is diabetic or not. So you can see till age, right? If we look at this till age, this is the independent columns you have, but outcome columns is dependent upon all these columns, right? Because this outcome is nothing but that person have the person has diabetic or not based on these 8 columns. So this is the thing you have to understand about the data set. Now we will look at the raw data set, and then we will start doing the data analysis, data pre-processing, and lastly we will do the classification model using Naive Bayes. Now, as we have talked about the data set, now we will start working with few libraries in Python. So these libraries are Pandas, NumPy, Matplotlib, and Seaborn for data pre-processing and data visualization. And for machine learning, like using Naive Bayes and machine learning libraries, we are going to use scikit-learn. So here you can see I am going to import Pandas as PD and then import NumPy as NP. Now, if you see for the data visualization, we have used matplotlib.pyplot as PLT and import Seaborn as SNS. Now, I will show you how to basically start with importing your data set and then just to read your data set using Pandas. And then we will have a look at the raw data set as well. So, as you can see over here, there is a square symbol over here, as we are going to use Google Colab. So in this case, you can see over here, if you just click over here that upload session storage, right? If you just click over here, wherever your data is got downloaded, suppose for my case, Pima Indian Diabetes, and then enter. Right, so I have 2 data sets with me, that is one is Pima Indian Diabetes and one is diabetes.csv, both are same. So you can see this, your data set is already here in the storage session. Now if you want to see the path, if you just click over here, you will get the option of copy path. Right, now just to read the data set, that is read CSV using Pandas, we just need to write data equals to pd.readcsv, and in the quotation you have to provide the you have to provide the dataset path. Now, if you just click over here, you just execute your code, you can see it's already executed. Now, if I just look at the code, what actually it has, so here, yes, let me make it a little big. Just you can see what is the raw data set we have. So you can see we have pregnancy. That particular person is pregnant for 6 times. Glucose is 148. Blood pressure is 72. Skin thickness is 35. Insulin is 0. That cannot be possible. We will talk about that. BMI equals to 33.6. Diabetes pedigree function is 0.627. Age equals to 50. Outcome 1. That means this particular person is nothing but diabetic. If we look at the next person pregnant for 1 time, glucose is 85, blood pressure is 66, skin thickness is 29, insulin is again 0. That cannot be possible. We will need to handle those problems. Then BMI is 26.6, diabetes pedigree function 0.351, age is 31, outcome is 0. This particular person is not diabetic. Right? So whenever we have data set, this is the class, right? When your person comes under 1, this is diabetic. When your person comes under 0, this is non-diabetic. So basically you have 2 classes. One is diabetic class, one is non-diabetic class. So whenever you have in your data set, you have class and you have a outcome column, not particularly outcome, the column name is no. If you have a column, dependent column, which is dependent on the other independent columns you have, that time your data set is nothing but is a categorical data set. But in the case, maybe you have a independent data, right? You have independent data and columns, and you have dependent columns as well, but the dependent columns is in nature is a continuous value column. So that case you have to go for regression. So these are the basic things you have to understand when you are to start working with the data set, right? So this is your data set description for the raw data set. Now as we have you can see we have actually read the read csv function, and this csv function is nothing but it reads the comma separate value data set, right? Now, if you want to just look at the first 10 rows of your data, how to do that? You just need to write data.head. So basically, if I just clear this part, if I just write data.head, it's going to provide me the first 5 rows, right? In default, it's like actually returns first 5 rows of your data set. So here you can see you got 0, 1, 2, 3, 4, right? So now if you just write 10 over here, you will get the first 10 rows of your data set from 0 to 9. Can you see you got 0 to 9? From the first itself you will get. Now if you want to see the last part of your data set, that time you have to use a function called .tail function. In default, it returns the last 5 rows of your data set. You can see 761, 766 and so on. And again, if you just do the same thing the way we did with head, so data.tail, that is tail 10, you can see 767, 766 till 758, right? So this is how you can visualize your data, the first 10 rows or the last 10 rows. I mean, it's up to you how much you want to see, but in default, if you don't put any number in the parenthesis, then you will get 5, 5. Right? Now, if you just look at the shape of your data, how many columns you have, how many rows you have. In this case, you have to write data.shape. It's going to return you first how many columns, how many rows you have. So in this case, you can see total you have 768 rows and 9 columns. Right? Now, it's already head part is done. Now we are going to start with missing value detection. If you have any missing value, that time you have to treat them. Otherwise, if you're going to make a model on this data set without do the data pre-processing, your model will not give you a good prediction, not even a good accuracy as well. So in this case, first we are going to look at the blank values, the NaN values, the null values, and if you have some continuous columns, they might have 0 that can be counted as a missing value. Now, to check the missing value for the very first time, what you need to do, you need to call the function called .info function. This function is going to return you what are the null values you have in your data set plus what is the type of your columns. So pregnancy is glucose. For all the columns, you don't have any null values, but you don't know if there is any continuous value which is consist of 0 or not, because it's going to check this info. Basically, it's going to check if you have any data like that is right as NaN or the blank. But if you have something in that place, it's not going to count that. So in this case, the record shows for all the columns in 768 that indicates there are no null values. Now, if you look at the data.description, so there is one more way to check the null values. You can write data.isNA. Right? So if you just call .isNA function, it's going to return you if you have any null value or not. So if you want to just see the summary of this, then you just need to write .NE. If you look over here, if you can see, you got pregnancy, glucose, blood pressure, skin thickness, insulin, BMI for all the columns, right? For all the columns, you get false. Why? Because there is no null value for this particular data set and for these particular columns. So in this case, you can see that data.isNA.NE is going to check for each and every column and each and every rows you have in your data set. Is there any null value is present or not? So if it's not, then it's going to return you false. If it's yes, it's going to return you true. It's basically the Boolean value. Now, if you just look at the data.describe, this describe, it's nothing but to help you understand the data description. So in this case, this pregnancy is glucose. If you look over here, what are the rows you not here? What are the rows you got? You got count, mean, standard deviation, minimum value you have in your data set. Then 25% IQ word, that interquartile range. Then 50%, then 75%, and then lastly we have max, right? So if you look over here for glucose, the minimum value is 0. It cannot be possible a person has 0 glucose in their body. Then there is one more, that is blood pressure. There is 0 is present. Then skin thickness, that is 0 is present. That cannot be possible. Then insulin again, that 0.00 we have seen that is present. That's not possible. A person without body mass index, that is also not possible. So these are the things. This is nothing but these are the columns has. These are the columns have basically the null values, right? So these are the column have the null values in the term of 0. So how to use this, how to remove this missing values? So from the above description of the data, we can see columns pregnancy, glucose, blood pressure, skin thickness, insulin, BMI have minimum values of 0, right? So it makes no sense to zero pregnancy. It makes sense to 0 pregnancies, but that did not make sense for 0 glucose, blood pressure, skin thickness, right? So we can understand that these are the columns have with missing values. Now, how to actually handle these missing values? So here we are going to replace 0 with np.nan. For that, if we go for using .isna.any function or .info function, we can understand actually how much we have with the null values. So if you have a big number in your data set with the non values and missing values, basically that time that data set is not perfect to work for. So in this case, we are going to use dot replace function, replacing 0 with np.nan. So for that, we have imported from numpy import nan. So you have written data of glucose, the data you have, the data of glucose, the particular column equals to data of glucose dot replace 0, np dot nan. So for all the column we have that missing value, we are going to do the same thing. Now if we just write data dot head, you can see for glucose, there is no non values, but for insulin there is 3 back-to-back nan values. For skin thickness also nan values are there. So the first 5 rows of your data. Now if I just write data dot head dot is null, right? So it's testing, but it's going to check is there any null value you have or not. Now I am just going to remove this head part because I don't want to see for particularly for first 5 rows. I want to see for the whole data set. Okay, I will get an error dot. Here you can say after replacing zeros with nan, so in that case data dot is null dot is any. So now you can see your glucose has missing values, your blood pressure, skin thickness, insulin, BMI, right? These are the columns with the nan values. Now if you just want to see what are the numbers, like dot is null dot any is going to check is there any column and any rows is there with the nan values. And here we are going to check data dot is null dot sum. What is the total number of records you have in your data set with the null values? For glucose, you have 5 records. For blood pressure, you have 34. For skin thickness, you have 227 records without any number or without any kind of information. For insulin has the highest, that 374. So this is how you can understand your data. These parts we are doing basically to have a good idea about what data set we are going to use. Right now, if you just need to, if you find out the missing values, now you have to use some techniques to remove the missing values. But how to do that? So missing values, it's like can be treated with the median, because median is the most least affected by the outliers. Now you will ask me, what are the outliers? Maybe the error in the data set. You can for time being you can understand outlier is nothing but your error in the data set. If you just write data dot median for all the columns, it's going to give you the median, right? For pregnancy, glucose, blood pressure. Now we are going to use one particular function which is known as dot fill any. So dot fill any is going to fill the nan data you have wherever with the median of that particular column, right? So for that, we have written data.fieldNA and data.median, then in place equals to true. Now, if you want to see the data.isNull.sum, after replacing your NA values with median, you can see it becomes 0 again. So this is how you can treat your missing values. Now, if I just look at the outlier detection, outlier is nothing but your error in the data set, right? So outlier detection, for the outlier detection, the best way to do the box plot. So box plot is help you to detect the outlier in your data set. In this case, we are going to write plt.figure and then figure size. The figure size we want that is 20,15. Then subplots. For one particular frame, you will get different box plot. That's why we use subplot. So for box plot, pregnancy, glucose, blood pressure, we are going to use cbond dot box plot, right? Skin thickness, everything, right? Let me just execute this. Yes. So if you look over here, if you get these dots are nothing but the outlier you have in your data set. So for pregnancy, you have outliers. For glucose, you don't have any outliers. For blood pressure, yes, you do have. For skin thickness, for all the cases, you have outliers. In the case of insulin as well, you have outliers. Now you want to handle these outliers. But how to handle these outliers? In order to handle these outliers, you just need to use or clip your data with a lower range and with a higher range. So clipping your data is nothing but to help you to sort out the outlier problem. So apart like from the above itself, you can see from apart from glucose, all the other attributes shows the presence of outliers. So this is with the lower level and the upper level of the outliers will be replaced by 5th and the 95 percentiles respectively. So here we are going to clip our data with the first 5% and the 95% percentile. So in this case, in order to do that, how to do that? We have written dot clip lower equals to data pregnancies and dot quantile is the lower part, you have written 0.05. For the upper data, you have given data pregnancy dot quantile 0.95. So this is how we actually handle our outlier. This is a very basic part. Now if you just plot the same plot whatever we have done few minutes before, you can see for pregnancies, glucose, blood pressure, skin thickness, these are the things is actually without outliers. There is no dots in the data visualization part. So you can see or you can say it fact that yes, we are actually able to come out from the outlier analysis problem, right? So this is how we have done this. And for skin thickness, age, insulin. But for the case of insulin, there is outlier is still there. In this case, how to do that? In this case, again, we are going to do this change the, if you can look over here, we have changed the quantile from 0.5 to this is 0.21, right? And the upper quantile is 0.80. So this is something we need to tweak our quantile range to get out of the outliers, right? So this is how we can actually go for using box plot to understand, do we have outliers in our data set? Because if your data set have missing values and outliers both, it will not work properly whenever you are going to make a model, right? Now, if you just look at the data visualization part, you can go for checking your data. So in this place, you can see for the data visualization, I am going to use SNS.count plot. This plot is nothing but automatically count the same data, like maybe we have two class over here, class 0 and class 1, class 1 for diabetic, class 0 for non-diabetic. In this case, it automatically count the 0 and 1, it will make the two particular class, that is 0 and 1. So 0 is non-diabetic and 1 is diabetic. From the data set itself, you can see we have a patient in our data set with non-diabetic features the most, right? Now, this is how we can actually understand our data set. Now what we are going to do, we are going to make the model. But how to make the model? In order to make the models, if you just want to look at the how many columns and what are the columns you have in your data, you can just write data.columns. You will get all the columns you have in your data set. Now to use the scikit-learn, we are going to use train test split. So why? So you can know that for the machine learning purpose itself, we need to divide our data set for training and testing. But why? Because training parts, whenever we are going to train our data, we are going to give the data set of trained data set. And the test data set will, like the machine will have no idea about the test data sets. So basically we will understand how our machine is working after getting trained with the data set. Whenever we are going to give a new data, how it's going to give us the predictions. Right? So for X, we have dropped the outcome. So for X, we have total 8 columns, which are the independent columns, and Y will have the outcome. So we are going to divide our data set into two particular part for not two particular, for four particular part. For one is for training training part for X and training part for Y, and then for test as well. Yes, for one for X training, one for Y training, one for X test, one for Y test. Now we are going to call a function called train test split, and we are going to provide X and Y. X will have all the independent columns and Y will have the dependent column. Right? And the test size will be 0.2. This is nothing but your 80% data will go for training your model and 20% for checking your model, how it's going to work. Now we have written random state equals to 0. So now if you just write random state equals to 40, it will haphazardly will start taking your data for training and testing. There is no proper way that you can say, hey, this random state, if I just don't write random state, so in that case, you will get the first 80% of your data for training and the last 20% of your data for the testing. Right? So now if you just import the naive Bayes from scikit-learn itself, you just need to write from sklearn.naive Bayes import Gaussian NB. So now if you just create a Gaussian classifier, there's nothing but naive Bayes classifier. You give a variable name model and you have called Gaussian NB. Now we are going to use model.fit. So model.fit basically we are going to use for train our model. So .fit is used for training our model. So X train comma Y train, right? We are going to give that X train and Y train. So in the case of X train, we have passed all the values for particular 8 particular columns, and for Y train we are going to pass the outcome, right? So if I just execute that, after that, let me do that. I don't even execute this part. Right. Okay. So here what we are going to do, if you can see that Gaussian NB is nothing but your model got trained. Now for the prediction, what we are going to do, we are going to write model.predict and then we are going to provide our test data. Now this time we are going to predict the class, right? The class we have that 0 and 1 based on all the independent columns we have. So we have passed that model.predict then xtest, right? Okay. Now if you just print predict value and if you just see the predicted value, what the prediction is, you can see all the classes you got depending upon the independent columns you have. Right? So now if you just import metrics to understand what's your accuracy, particularly for naive Bayes, you can see your accuracy is 0.75. So it's pretty cool. It's not bad, but you can, using some more data analysis techniques and data pre-processing techniques, you still can improve your accuracy. In this particular course, we have talked about what is machine learning, how to build a machine learning model, what are the steps you need to follow to build a machine learning model, what is supervised learning, and also what are the types of machine learning we have. What is supervised learning? What are the algorithms comes under supervised learning? And also we have talked about two basic algorithm that comes under supervised learning, that is naive Bayes and logistic regression. And we have done two different projects on naive Bayes and logistic regression. One is predicting diabetic patient and second one is predicting credit card fraud transactions, right? So this is all about the course we have learned so far. I hope this course will help you to understand, to get started with machine learning and also get started with the few algorithms of machine learning. Thank you so much.
I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains Absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.